Okay, hello everyone. This is a video about parallel and perpendicular lines and how you can tell if things are parallel and perpendicular based on their slope. So first I'm going to show you some stuff in Desmos. So here we have, I've written a bunch of equations and they're kind of coming pairs, so I'll toggle this one on. Here you can see the red equation is y equals 1/2 x plus 3, so the slope is 1/2. You can see it going up 1/2. And I've drawn a perpendicular line right here. So visually you can look at it and see that the red and the blue line are perpendicular to each other. Can I write on this? I can't. And so they meet to form a right angle. And so I want you to look carefully at the slopes of these two lines. We have 1/2 and then we have -2. All right, and then I'm going to turn these off and go to another pair. Here we have another line, 3/2 x minus 3. Slope is 3/2, and it's perpendicular line. So we have green and the purple, and look at those slopes, 3/2 and -2/3. And so what you can hopefully see, and what we're going to learn, what you're learning today, is that slopes that are perpendicular are opposite reciprocals of each other. Opposite meaning the opposite sign, reciprocal meaning flipped upside down as a fraction. So 1/2 and -2. If you turn 1/2 over, you get 2/1 or 2, and you make it negative. Therefore, they are perpendicular. 3/2 and -2/3 are opposite reciprocals, and they're perpendicular. So, here is a line where I've only have one part of the pair, and the line is y equals 1/2 x, or is 2x plus 5. So my question to you, and you can just think about it for a second, what would the slope be of a line that is perpendicular to that? So we want to write an equation, so think about what would the slope be. And so hopefully you said, if that slope is 2/1, then the opposite reciprocal is -1 . I'm on an iPad, I don't know how to do a fraction. That's not it. And what you can see right there is I just typed in y equals -1/2 x, and I don't even have a y-intercept typed in, so the default would be 0, and so that's perpendicular. Now I can add 1, and that's perpendicular. I can add 2. So any line with the opposite reciprocal slope is going to be perpendicular, and the y-intercept doesn't really matter. It's just moving it up and down, but the slope is staying the same. So hopefully that makes a little bit of sense. Now I'm going to show you how we can apply this. One way we can apply it. So I'm going to flip over to Jamboard, and here's the type of question you're going to be doing today. Write the equation of a line that's perpendicular to y equals 2/5 x minus 3 and goes through the point 4, -2. So you could graph this if we wanted, just so we could see what it's looking like. So y equals 2/5 x minus 3 has a y-intercept of -3 and goes up 2 to the right 5. And so that's what our line looks like. Now we're looking for a line that's perpendicular to that. And so the first step is the line we're looking for, because it's perpendicular to that, our slope is going to be the reciprocal opposite. So that's positive, so it's going to be negative. It's 2/5, so we're going to flip it upside down and say -5/2. And now this just becomes the problem that you've done a lot recently, which is find the equation of a line where you know the slope and you know one point. So we know the point 4, -2, so we can put -2 in for y, 4 in for x, and now we're just solving for b. B equals 8, and so the equation that we're looking for is y equals -5/2x plus 8. If we want, we can graph it. Here's the y-intercept, down 5/2, and you draw it. You don't have to draw these, but just so you can see that visually that does seem to make sense, that those two lines are in fact perpendicular. So that's how you determine what the slopes of perpendicular lines are. Now, I think you've already learned that parallel lines have the same slope. So that's not new information, but the new information today is that perpendicular lines have not just the reciprocal, not just the opposite, but opposite reciprocal slopes.